Hi, this is Ganesh. My topic in radar engineering is radar block diagram. First, in radar block diagram, there will be an antenna in which it will be connected to a duplexer, and then from it will be connected to a transmitter. From that, it will be connected to pulse modulator. From duplexer, it will be low noise RF amplifier, and it will be given to mixer, and it will be given to IF amplifier. That means matched filter. And it will be given to 2D detector, and next video amplifier, and next display. Now there will be two sections of radar. There one is transmitter section and second one is receiver section. So radar shown in the block diagram is called monostatic radar, since same antenna is used for transmission and reception. First one, transmitter section, the first section. In that transmitter may be a power amplifier such as Klystron traveling wave tube or transistor amplifier. This will generate electrical energy at radio frequency. The next one is pulse modulator. The power amplifies produces a high power signal, maybe in terms of megawatts. Pulse modulator shown in the block diagram, you can use it as switch, which will turn on and off the power amplifier. And the next one is waveform generator. A low power signal is produced by the waveform generator, which is given as an input to the power amplifier. Next one is duplexer. The next one, the duplexer allows a single antenna to be used as on a time shared basis for both transmitting and receiving. The next one, the duplexer is generally a gaseous device. It produces a short circuit at the input to the receiver when the transmitter is operating, so that high power flows to the antenna and not to the receiver. On the reception, the duplexer directs echo signal to the receiver and not to the transmitter. Solid state ferrite circulators and the receiver protector devices can also be part of the duplexer. And the receiver section, now coming to the receiver section, there will be low noise RF amplifier, mixer and local oscillator, and IF amplifier. First one, low noise RF amplifier. The receiver is always a super heterodyne LNA, that means low noise amplifier, is used immediately after the antenna. This reduces the noise figures and produces the RF pulse proportionally to the transmitted signal. And the next one is mixer and the local oscillator. It converts the RF signal to an intermediate frequency where it is amplified by the IF amplifier. The IF frequency might be 30 or 60 MHz. And next one is IF amplifier. Here it amplifies the IF pulse. IF amplifier is designed as a matched filter, which maximizes the output peak signal to mean noise ratio. The matched filter maximizes the detectability of weak echo signals and attenuates unwanted signals. The signal bandwidth of super heterodyne receiver is determined by the bandwidth of its IF stage. Next, the signal bandwidth of super heterodyne receiver is determined by the bandwidth of its IF stage. For example, when a pulse is of the order of 1 microseconds, the IF bandwidth would be about 1 MHz. And the above and the continuation of the receiver section is second detector and video amplifier and threshold decision and display. Second detector, the IF amplifier followed by a crystal diode, which is called the second detector or demodulator. Its purpose is to assist in extracting the echo signal modulation from the carrier. It is called as second detector since it is the second diode used in the chain. The first diode is used in the mixture. Output of the second detector is the video pulse, the video amplifier. It is designed to provide the sufficient amplification to raise the level of the input signal to a magnitude where it can be displayed CRT or digital computer. Here we are discussing this video amplifier that it is designed to provide sufficient amplification so that the input level to a magnitude. Next one in this chain is threshold decision. The output of the video amplifier is given to the threshold detector where it is decided whether the received signal is from a target or just because of the presence of the noise. Thank you.